Good morning again. We were talking about ohmic resistors and non-ohmic resistors. So let's read a little more. Read out. We were talking about ohmic resistors. After this, we are moving to the next part, which is potential dividers. Very important part. Potential dividers. Now we are going to move. We are moving to the next part, very important part, which is potential dividers. Potential divider is a circuit. It's a circuit that we can use to get a particular potential value from that. So you can see the circuit here. So in this circuit, the output is this part. This is the output part. The output is this one. This is the output. Okay. So from using this one, we can light up bulb. We can use for a buzzer. So a lot of things we can use this one. Okay. But we don't need to consider those parts. Just we have to think about output voltage. Okay. So how we are going to find the output voltage? So here I'll start with the Ohm's law. I'll start with the Ohm's law. Here we can have V in is equal I both of R's, R1 plus R2. R1 plus R2. Okay. R1 plus R2. Then I'm going to subject I. Then I'm going to subject I, which is V in R1 plus R2. This is our first part. Now what we are getting, I need to find the V out. V out is equal, against Ohm's law, I R2. Finally, I'm getting a value for V out. I'm substituting V in here. I value V in R1 plus R2 into R2, and V out I am getting R2 over R1 plus R2 times V in. This is what we call potential divider. So output of the potential divider. This is the output of the potential divider. In the tutorial, we have a question, a typical exam question. A potential meter divider form. Rheostat means variable resistor connected in series with a fixed resistor 4 kilo ohm. Both are connected across 12 volt supply. Initially, it is 10 kilo ohm. Calculate the potential across rod, and we explain without further calculation what will happen to this value of the output signal. Resistance R is decreased. So That is a little bit confusing question. I'm going to erase this part. So now I'm getting a potential divider form with a resistor and rheostat means a variable resistor. Resistor and variable resistor. And it is 4 kilo ohm. And initially R not initially it is at 10 kilo ohm. And this is 12. 12 volt is the supply, that means V in is 12. You have to calculate potential across this one, which is V out. So finally, you can write the equation V out is equal R naught over R naught plus 4 into V naught or V in. R naught is 10. This is 10 plus 4, 14 and 12. Finally, you are getting the value for R naught as 10 over 14 into 12, 8.6. 8.6. It is voltage. 8.6. Okay. So second part, explain without further calculation what happens to the output signal if the resistance R is decreased. If R is decreased, what is happening? R is decreased, what is happening? Output resistance, you can see here, this is decreasing and this is also decreasing, but this decrease is basically we have constant value now, so this decrease is not that much important. The R naught value is decreasing, so then basically what would happen to the potential here? It also get decreased. The potential also get decreased. Okay, so you can write V naught is here. V naught is proportional to the R naught. Therefore, if this decrease, this also decrease. And now we are moving to the next part: electrical energy, energy of a circuit, and electrical power. So, if you remember, work done, we wrote earlier, the work done is equal voltage into charge, and W is basically energy. VQ, again current is equal, we know the current is equal Q over T. The current is equal Q over T. So we can subject Q, which is IT, and this is first equation. This is second equation. By first and second equation, we are getting W is equal VIT, or in another manner, we can say energy is equal VIT. Energy is equal VIT. Okay, we know the Ohm's law, V equals IR. In this equation, instead of V, we can put IR. So then we are getting IR, IT. So what is I squared RT? So the second equation for energy is I squared RT. Again, instead of I, we can use I is equal V over R. I'm using V over R for I. I'm getting E as VR squared into RT. Finally, RR cancel out. I'm getting V squared over RT. So the third equation for energy is equal E is equal V squared over RT. So these are three equations that you need to remember about electrical energy. So that is in your tutorial as well. So this is the proof of that. So power we know from the mechanics, power is energy over time. Power is energy over time. Energy over time. And by all the energies we can do for power equation, first we have VIT over T. The second equation we have I squared RT over T. And third equation we have for power. Also I can write after this two. P is equal then VI and I squared R. These are two equations for P. And we have another equation, P is equal V squared RT over T. Finally, we are getting the third equation for P, V squared over R. These are the equations for that. These are the equations for that. Okay. We can move to the next part, electromotive force. What is electromotive force? As I told you, the electromotive force is the force, electromotive force is the energy stored in a, we have two definitions, energy stored in the battery or cell. And we can say another way, if we connected a battery or cell into a short circuit, that is also has the EMF of the, that is also has the EMF of the battery. Okay, so the next one is internal resistance. Internal resistance. What do you mean by internal resistance? What do you mean by internal resistance? So normally, for ideal cases, ideal means things that can never happen. So ideal ones, what you get it is the theoretical one. For theoretical one, you don't have any, for theoretical one, you don't have any resistance. Theories වල තියෙන දේවල්, පොත්වල තියෙන දේවල්, ෆිල්ම් වල තියෙන දේවල් කවදාවත් ජීවිතේ දෙන්නේ නැහැ. Real situation and real දේවල් ඒ දේවල් වලට ගොඩක් වෙනස්. හරි? ෆිල්ම් එකක් බැලුවම ඕගොල්ලන්ට තේරෙනවා ඇති. Normally if you have, if this is the hero, others shooting 100 times, none of the bullets are going through him. Okay? යන්නේ නැහැ. හැබැයි ඇත්ත ජීවිතයේදී එහෙම කියලා ෆිල්ම් එකක් කියලා හිතලා කරන්න ගියොත් අනිවාර්යයෙන්ම මැරෙන්න වෙනවා. හරි? Same thing happens here. Okay, in theoretically you don't have resistance. Any resistance inside a battery. හැබැයි ඇත්තට ඔයා දන්නවා බැටරි දෙකකට වයර් එකක් දැම්මොත් බැටරි දෙකක් මෙහෙම වයර් එකක් දාලා අල්ලගෙන හිටියොත් ටික වෙලාවකින් ඔයාට රස්නයක් දැනෙනවා. ඇඟිල්ල රත් වෙනවා. හේතුව තමයි මේ බැටරියත් රත් වෙනවා. බැටරියේ resistance එකක් තියෙනවා. It has a resistance. It has a resistance. We call it the internal resistance. We call it internal resistance. Okay. Now internal resistance is that. මෙහෙම ගත්තොත් බැටරියක් with a resistor මෙහෙම ගන්නවා වෝල්ට්මීටර් එකකුත් මේකට කනෙක්ට් කරනවා ඕනනම් ඇමීටර් එකකුත් අපි කනෙක්ට් කරමු okay so මේ වගේ වෙලාවක if the current is passing through the circuit if the battery is a real battery this is a real not an ideal one this is a real battery okay now we consider a real battery it's a real battery අර ඉස්සෙල්ලා මම කිව්වා වගේ ඇත්ත ජීවිතයේදී වැඩි වදිනවා වගේ real battery එක it has a resistance so we have to add that resistance to the circuit that is there no so we have to add that so simple R E so E is the potential here we are going I so if we use the Ohm's law this is capital R consider this resistance as capital R so we have E which is equal I capital R plus I simple R voltage across this one and voltage across this resistor the voltmeter reading here gives us consider the voltmeter reading is V the voltmeter reading is giving us IR only capital IR because we are measuring the potential difference across these 2 points now we are getting IR මම ඒකකින්ද මේක subject කරන IR when I'm subjecting IR I'm getting E minus IR finally V is equal E minus IR for a battery I am getting. And there are some circuits, I'm not going to prove this. There are some circuits, in those circuits, the currents are moving through the battery. Current එක battery ඇතුලෙන් යනවා නම් the direction of the current is there are some circuits, okay? There are some circuits current are moving here. As an example, I can say if you have connected 2 batteries here in this manner, one is 6 and one is 3 volts. So because of the 6 volt, the current is going this way. So there are circuits that current is going through that. For that cases, V is equal E plus IR. These are the 2 equations. If current is going away from the battery, E minus IR. If the current is going through the battery, E plus IR. The 2 equations are these. If the current is going through it, it is E plus IR. If the current is going from it, it is E minus IR. Okay? That is for the internal resistance. Now, Kirchhoff's law, one of the most important laws. Before we come to the Kirchhoff's law, I have to tell you a few things here. Okay, so electrical circuit symbols. In tutorial, you have place to write electrical circuit symbols. Electrical circuit. Okay, so if you have something like this, or these are resistors. And I'm going with this manner. This is thermistor. Variable resistor. Now I'm going this way. This is LDR, LDR, light depending resistor, light depending resistor. And this is for voltmeter. This is for ammeter. Voltmeter, ammeter, and diode. Here, if you have two arrows this way, it is LED light emitting diode. If you have two arrows in this manner, it is we call photodiodes. This is a cell. This is for a battery. Cell. Battery. And this is what we call fuse. Bulb. Here, this is for switch. These are the circuit diagrams that you need to know. These are the circuit diagrams that you need to know. Okay. Now I'm moving to the next part. Kirchhoff's law. Kirchhoff explained two laws. The first law was coming from the universal law called charge conservation. Charge conservation. Charge conservation. And the second one is coming from energy conservation. Energy conservation. Charge conservation and energy conservation. First law said that for a junction of a circuit, incoming currents are equal to outgoing currents. Incoming current means here I1, I2, I3. I1, I2, I3. We can say outgoing current I4 and I5. I can take this into this side, then I'm getting I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. In another manner, I'm getting sigma I is equal 1 to n. So here I have only 5, but for a general equation, this is equal to 0. This is what we can tell about Kirchhoff's first law. This is what we can say about Kirchhoff's first law. Then Kirchhoff's second law said that the EMF of the battery is equal to total potential difference. Total potential differences. Total potential differences. Okay. And here what we are getting, sigma E in this side, total EMFs. Here we are getting sigma IR. Sigma E and sigma IR. Okay. sigma E and sigma I. Then, okay, so voltmeter and ammeter. Next part is the voltmeter ammeter. You can read it. So again, I am telling ideal voltmeters and ideal ammeters. You need to remember ideal voltmeters and ideal ammeters. Ideal voltmeter means ideal. What is ideal? The resistance of the voltmeter is infinity. Resistance of the voltmeter is infinity. Ideal ammeter, if it is ideal, the resistance of the ammeter is 0. And normally we are connecting voltmeters in parallel now. Voltmeters in parallel now. And ammeters in series manner. Ammeters in series manner. Voltmeter is parallel manner. Ammeters in series manner. Parallel series. Parallel series. And now I am coming to the Winston Bridge. It's a very important part. Winston Bridge. What do you mean by Winston Bridge? As I told you earlier, Winston Bridge is a circuit which gives us these two potentials 0. The potential difference across these two 0. So we have something called galvanometer. 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 What is a galvanometer? Galvanometer is basically an ammeter. This is an ammeter with the needle in the middle. It can deflect either side. It can show negative current and positive current. That means current is flowing in one direction or the other direction. It can indicate. That is we call a galvanometer. Consider now current is moving here, and then what happens to the current? Is dividing into two parts. I is the current. Here it becomes I1. Going here, I1. Here I2. Going here, I2. Okay. So I know that the total voltage is V. For V, I can write V is equal I1 R4 plus I1 R3. And another thing, I can write V for I2 is equal I2 R1 plus I2 R2. Okay, so the same equations. I keep in this equation and I labeling this place as A and this place as B. Okay, so potential at here I'm taking V initial, V naught, here VA, here VB, here I'm getting V dash. The potentials at these points. Potential at these points. Potential means voltage at this particular point. Potential, not the potential difference, potential. So I can get for this R1, I'm starting with R1. For R1, I am getting V naught minus, sorry, VB minus V naught as I2 R2. So I2 R1. This is my third one. Okay. And for this one, what I am getting, and I can write this as potential difference. This potential difference, I am giving a name VBO. Potential difference VBO is I2 R1. This is very important. You have question in this part, structure paper. You have question here. This is my, I'll write, this is that the first equation. This is my first equation. Second one for R4, also R2 I am writing, same way, R2 I am writing. Now I am getting V dash minus VB. V dash minus VB as I2 R2. This is second, I'll write in the next line. It is V dash B. I'm writing V dash B as I2 R2. This is my second one. Next one I'm going to write is for R4, the same thing. Same manner for R4 I'm getting. I'm not going to write everything. For R4 I'm getting RAO, sorry, VAO, I'm getting VAO as I1 R4 and R3 I am getting V dash A as I1 R3. I1 R3. Okay. Since this galvanometer says 0, since this galvanometer is 0, the potential VA is equal potential VB. Okay, so I will take that later. So this is my third and my fourth equations. So finally I am getting, I can divide 1 by 2, 1 by 2 I am getting VO over V dash B as R1 over R2. You also can do this for 3 divided by 4 I am getting 3 divided by 4 I am getting VAO over V dash A as R4 over R3. R4 over R3. So since so this experiment or this Winston Bridge, the galvanometer is the reading of the galvanometer current is 0. No current is flowing means the potentials at A and B are same. Potentials at A and B are same. So finally, what you can get, if the potentials of A and B are same, so you are getting VBO. Don't think too much, just think that you are getting VBO as VAO, they are same, and V dash B is equal to V dash A. So therefore, in these two equations, left-hand sides are equal. So finally, you are getting R1 over R2. R1 over R2 is equal to R4 over R3. R4 over R3. So this is basically the ratio between these two resistors is equal. If they are equal, we call this as a Winston bridge. We call this as a Winston bridge. And obviously, if the ratios are same, the middle line or the middle part become 0. So that was the thing that I have done the previous question. Okay, if you remember the question for the resistors, that was the thing that I have done. So that is we call the Winston bridge. That is we call the Winston bridge. If you have any doubt, you can ask now. If you have any doubt, you can ask now. Okay. Now the meter bridge. Meter bridge. Meter bridge is an equipment which we are using in the lab in order to show the Winston bridge. So it has copper wires which are thick. The reason is in order to get the less resistance of the wires, we have thick metal conductors. Thick metal conductors. Here we have wire. Okay, this part you need to listen carefully. After finishing this part, and there's another part called potentiometer. Then I'm moving to the questions. Okay, before I do the practicals, I'm moving to the questions. I need to do a few questions today. Okay, so now I'm getting meter bridge. So what is happening in meter bridge? We have one resistor here and another resistor here. One of this we don't know, and one of this we know the value. This is I'm taking X. Okay. And another thing in meter bridge, we have a galvanometer connected value here, and it has a jockey. We call this is a key, we call it a jockey. Okay, jockey is a key which is made out of metal in order to get the correct position or the correct value of the resistance. Okay, so what we are going to do is here we have to connect this into a circuit. Consider now we have the voltage across this V. Okay, now currents are flowing from these two parts. So what is happening here? This is the very important part. Okay, this wire, consider wire has total resistance R. Resistance of the wire R. This is very important, therefore listen carefully. Total resistance is R. Huh? So R has 1 meter length. 1 meter is the length. 1 meter gives by R. So 1 unit, this we can divide by 1 meter, and we can give a name for that. The resistance per unit volume, so unit length, which is we can say lambda. Let's say lambda. Unit length, the resistance is here. Here we have to find a place. We can find several places and we can put for those places our jockey. We can connect this wire for our jockey. Consider when we connected a place like this, we are getting L, length L. And this part we know that L minus 1 minus L is this, because the meter bridge means the wire is long 1 meter. This wire is 1 meter wide. 1 meter wire. It has resistance R or lambda as the resistance per unit length. Okay. So if we have L length, the resistance of that L part I am writing R1 is equal L lambda. Resistance of this space as R2, which is 1 minus L lambda. Okay, the important thing, we need to make this galvanometer reading 0. The current of the galvanometer is 0. If the current is 0, this is just or simply represent, this is just this manner. This is simply represent Winston Bridge. It has 2 resistors here. This is, if the galvanometer value is 0, here we have X, which is the thing that we need to find. R naught here. This side, the value become L lambda. This side, the value is 1 minus L lambda. So finally, we are getting X over lambda L is equal R naught over 1 minus L lambda from Winston Bridge. From Winston Bridge. Lambda and lambda will cancel out. X is equal R naught L times 1 minus L. So this is how we can find unknown resistor or unknown resistance of a resistor from a meter bridge. From a meter bridge. All of these notes are in tutorial. Go through them. Okay, if you have any doubt, again ask. If you have any doubt, again you can ask. If you have any doubt, you can again ask. Then we having something called potentiometer. Potentiometer. It is the next application. It is also something like this. Potentiometer. It has a wire. It is the length of the potentiometer is not necessary to be 1 meter. So it can be any value. You have the first circuit here. This side you have second circuit. And here we have, normally we can compare batteries. We can do lots of experiments using this circuit. Okay. So you have galvanometer here. Potentiometer means now if the length is L, if it gives total potential V, L is given V, then we can get unit potential per unit length. potential per unit length. Potential per unit length. So now what we are getting, lambda is equal V over L. V means the total potential here, and L is the total length of the wire. Okay, same as previous one. Okay, so this is how we can get this V over L. Any doubts up to now? This is the constant for a particular. This is the constant for constant temperature and particular constant temperature and particular material. Lambda is a constant. Okay, so here consider we have E1, E2, two cells. What we can do, we can keep again this jockey in a place that we are getting galvanometer 0. Galvanometer 0 means no current is flowing through this. Here, if consider it got a value L0 value. So the potential for that, we can find the potential is equal lambda. Consider when we connect it to this part, we are getting lambda times L0. Lambda means potential per unit length. So potential E1, I am getting then lambda L0. This is first one. Then I am connecting this to E2. Then E1 is not connected. Then E1 is not connected. Okay, E1 is not connected. Now it connected to this one. Now again G is 0. Consider it got a value like this, which is L1. So E2 I am getting lambda L1. So I can divide or I can compare E1 over E2 easily by dividing these two. Lambda and lambda will cancel out. I am getting L0 over L1. So I can easily compare these EMFs of these batteries using potentiometer. So previously we measured the resistance using meter bridge. You can see that here we measure the resistance, the potentiometer, the same thing that we are measuring potential. By length we are measuring potential here. In the meter bridge, by length we are measuring the length resistance. Okay, so these are the things that I wanted to discuss with you, and there are 4 practicals as well in the tutorial. You can go through them. So every detail that I need to put, I put in on the tutorial. So I think now it's better to go for the MCQ paper. At least I need to cover 20 questions. So let's move for that. Okay, you can download. If anyone didn't get, let me know. If anyone didn't get, let me know. I'll upload it again here. I'll upload it again in here. If anyone didn't get that, I'll upload it in here again. The MCQ paper is this one. Just check the chat. MCQ paper is I uploaded. and structure paper also I uploaded. MCQ answer. If you want, you can download it now. So we can go for questions. So I'm going to share the question paper. The first question, go through the first question and give me the answer. First question, MCQ paper. First question. Below diagram show a picture of circuit was set up with the measure EMF. E of a cell, ES is the standard cell. Standard cells we are using to calibrate or validate or calibrate the potentiometer. Okay, so standard cells we are using to calibrate or validate potentiometer. So I'll explain that. Okay. Standard cell. What is a standard cell? Standard cell. Standard cell means a cell which we can use. We can use to calibrate. What do you mean by calibrate? So consider we have potentiometer. We didn't know the potential. Then what we are going to do, we are using a standard cell, and by standard cell means it is R is equal to 0. Therefore, standard cell we can find the where the place is. Consider 50 meters, we got 50 volt. So finally we can say 50 volt divided by 50 centimeter is 0.5. So we are getting 100 volts per meter. So that is how we label in this. So standard cells we are using. Standard cells we are using. We are using standard cells to calibrate. Therefore, which is the incorrect one? ES, E must be greater than E. Okay. What do you think about that? I'll keep that one. I'll keep that one. Below, okay. ES must be greater than the internal resistance of the standard cell, not important for this practical. When we labeling or calibrating a potentiometer, the current across this is 0. The current across this is 0. Therefore, we don't need R value. So we are not considering R value. That is not important. That is not important. So that is correct. Second one, the neutral point depends on the internal resistance of A cell. This is the A cell. So internal resistance is depend on that. Yes, if the internal resistance change increase, this value getting decreased. So therefore, that is depending on internal resistance. That is also correct. All the batteries of the circuits are connected correct manner. Yes, plus and plus here. That is correct. The cell needs to the current to the jockey. Yes, that is also correct. The thing that is wrong is ES must be greater than E. So there is no connection between that. Answer is A. Answer is A. There is no connection between that. Next question. Next question. Actually, this question, the question that we just did, was a past paper question in 1999. Those times we had 60 questions. 60 questions. This is the 51, question number 51 of 1999. This is the fifth question, 51 question, or the 51st question in 1999 paper. Okay. Again, I'm telling, so in this practical, you don't need to consider the ES and E values. Okay, next one. I'm erasing the board. Question number 2. Question number 2. Read the question. Question number 2. Read the question. It is again a past paper question, 1998, 25. 25th question of 1998. So these papers you are not getting in English medium. All the papers are in single medium. So, and you are getting the answer for this particular question. You are getting the answer for this particular question. Once you look at the question, you can find the answer. So first one, energy of the cell. Second, they're asking about this circuit. They have this circuit here. Another thing. Okay, so I know it is a little bit hard to do online classes for like physical classes. It's hard to do around 5 hours, 6 hours. So even though, as I think that the time is not enough for this one, so even though we won't be able to cover full papers which I submitted to you, I'm only doing first 20 questions of MCQs, and I want to do 4 questions of the structure paper as well. Okay, if I'm not getting all the time that I need, I'll arrange another session to cover the things that I won't be able to cover in this session. Okay, so without any payment, you can come to that one. So yes, I know that this time is a little bit tough for everyone. So without any payment, you can come to that class as well. So if we won't be able to, I think that the time is not enough to cover everything here as I expected, because I need to cover all 50 questions, and then I have to go for MCQs, and I have another part for essays. So I need to cover everything for you, but the time is not enough. And another thing, it's very hard to stay. Most of you, it's not comfortable with sitting long time. So some of them might get migraine. So some of them sending me messages, I'm getting migraine like that. So don't worry about that. if you can't stay here, I'll put the recording to your group as well. So you can go little by little while little time you can go out and then you can come back. Okay, somehow we have to get used to this. Okay, and another thing, A level is the hardest exam that you are facing in your life. Okay, A level is the hardest test. Okay, I went to UOC, University of Colombo. I did only one shy. First shy I got selected for the university. The reason is I want, as I told you earlier, I wanted to be a scientist. I wanted to be a scientist in uh, astrophysics. Astrophysics. At the moment, I'm trying to do that part. At the moment, I'm doing some researches. So I always want to be going scientific stream. But most of the students, they are not selecting science as a subject. I don't know what is the reason. In our batch, we had 500 students. 500 students got selected for science. 500 students, out of them, almost 250, 50%. So I was a union member of the university that time in the UOC. I was a union member. So almost 250 students left the country. Most of them migrated to the US, some of them in UK, and some of them in Aussie. Okay, so for my opinion, if anyone ever wants to go for higher studies, anyone ever wants to go for another country, so it's a best place that you can come is UOC. So if you got selected UOC means that is like simply like you got visa for USA. Okay. Basically, except few of us who wanted to stay in Sri Lanka, and the rest has left the country. Okay. So if you want to come here, go higher studies, if you want to go abroad, it's the science stream is another basic part. Okay, so most of you thinking of only about engineering. Yes, engineering is good if you stay in Sri Lanka, but if you want to go, or if you want to increase your knowledge horizons, so science stream is the best, and it's very fun. The exams are not that much hard, and it's a very, actually the university life is very fun. Okay, so first year you are getting, when you got into the university, first year you are getting something called teller. Okay, from that day it's very fun. Okay, some of my, you might think it is not. So some of you might think campus always rags and strikes, and believe me, for our 4 years, I did 4 years as student, and 1 year I spent there as a demonstrator. Okay, so all 5 years, none of the days that the university was closed. All 365 days it was open. So don't afraid to go local universities. Don't afraid to select science streams. You have a path. So I had a friend at the moment, he's studying at University of Oxford for his PhD. He got 2.5 and he was 51st of the country. And in my year, there was a student from Jaffna. He was the first of the country, and he selected science. And my younger batch, so Rusiru, he was the Hambantota district island first, and he also did mathematics special in our university. So lots of students are selecting that. So again, don't think that science streams are not good. So if you selected for a university, even if you got something like 1.2, that is also okay. I got 1.78. My the 1.14 was my years asking for the science stream. So I had capability to go University of Moratuwa for a QS, and if I do second shy, I was able to go for engineering as well. But I didn't go for that. I selected this part. So if any one of you like to select scientific stream, you can. This University of Colombo is a good place to you. Okay, so saying that, I'm coming back to the lesson. Here in this circuit, so this is very easy part. So energy of the cells, no, that is not you are getting from EI. EI is not cell energy. Power, no, not power. So 2 and 3 will cancel out. Energy of the dissipated through R, no, energy dissipated through R we can get from IR square T. So this is not the thing that they have given EI. That is the energy of the circuit. Sorry, it is the power of the circuit. Power, if you remember the equation for the power, power is equal voltage into current. Voltage here is EMF and I. So EI is that power of the circuit. Power of the circuit. Answer is here. Okay, so there is a mistake in this question. The question, the fifth one has to be, it's a printing mistake. It's a printing mistake. Okay, so the one who typed it got wrong. So the fifth part, fifth answer, you have to change. It is the power dissipated. Power, not the energy. Power dissipated. Power dissipated through the circuit. Through the circuit. Power dissipated through the circuit. Answer is the power dissipated through the circuit. Then we can move to the next part. It is power. Change, do these changes and write down them. After that, you can do that as well. Okay. Question number 3, I'm giving you a time, 2 minutes. Try to do. Question number 3, I'm giving you a time. Quickly do. Let's check who can do this one. Let's check who can do this one without my help. Try to do this. Every theory that we want to do these questions, I told you in the theory part. Okay. This is also a past paper questions. First 20 questions. Every question from the first, all the first 20 questions, I was grabbed from past papers. 1999, 40th question. 1999, 40th questions. I don't think that you have ever made these kind of questions. 1999, 40th question. It is 1999, 40th question. The question says, find the V over V naught value. V over V naught value. Try to find it. Try to find it. I'll give you the time to do that. This is R. This is R. Okay. Normally, if you're getting MCQs, you don't need to do MCQs with equations. You don't need to do MCQs with equations. Answer is B. Good. Rismi, you got correct answer. That's good. It is the correct answer. Anyone else got that answer? B is the answer, 1/5. Good. How you can do that? Here we have RR, 2R, and this is what you're getting, 2R, R, and R. We can simplify further this circuit. We are getting this is. There is another easy method to calculate parallel two resistors. So the easiest method is just you have to multiply. If they are not same, you have to multiply two resistors and add two resistors, 2R plus R. So finally you are getting 2R/3. So this is the, you can do in the other manner as well, you will get the same answer. This is the easiest method. You can multiply two resistors and add two resistors. So here we have R. So we can find from here this voltage, V dash, I'm telling you. V dash is equal, by potential divider technique, you can get potential divider technique. R means 2/3R divided by 2, 3R plus R. Potential divider technique, I need the potential of this part, this resistor divided by total resistors. This resistor is 2/3, then I need to divide that by total resistance and multiply that by the V0. Finally, I'm getting here 5R/3, 2, 3R, 3 and 3, R and R cancel out. I am getting 2/5 V0 as V dash. Okay, this is for here. The voltage here is 2/5 V0. You have two R's, same values. The resistor is divided equally for these two parts. It is dividing equal to this part. So V dash we found, half of V dash is equal to potential across this, which is V. Half of V dash is half, 2/5 V0. Finally, this and this cancel out. I am getting V/V0 as 1/5. 1/5 is the second answer, B. Answer B. Again, I am telling a different method. We can analyze this method. Okay. So if we are getting 2 V0/5, here we have, again, first we can analyze by mentally, we can analyze this is 2R, this is 1R. Therefore, if you get in 2R and 1R parallelly, the resultant resistance become 2R/3. 2R/3. So just you have to do the method that I told you. You can multiply this by this and you can add this to this. So finally you are getting 2R/3. And that gives us 2/5 V0 as the potential across the resistor here. This and these two resistors are parallel to each other. Therefore, this voltage belongs to this one and this one. So since these two resistors are same, the half of the 2 over 5 V naught dividing by both. So half of it we are getting 1 over 5 V naught value. So V is equal 1 over 5 V naught. They're asking us V over V naught value, which is 1 over 5. Answer is B. Okay. Then next question, go to the next question. It is 1998 50th question. It is 1998 50th question. You can do that question. You can do that question and tell me the answer. If you got the answer, tell me it. If you got the answer, tell me it. Draw the resistor diagram in your book or papers that you have. Please try to do this one. Okay. Now I'll do this. Again, think about these potentials. Potential at here and potential at here. Again, think about potentials. Okay. Now, the potentials are same. This is simply line, single line. Therefore, you can draw that here and this manner you can draw. You can simplify this. Same line. You can change these things here and there. It doesn't matter because the potential is same for all places. This is y, this is x. This is 1 and 1. This is 3 ohms and 1 ohm. Yes, your answer is correct. Good. Okay. 3 ohm. And here 1 ohm. 1 ohm, 1 ohm, 3 ohm, 1 ohm. So Y is here, X is here. So 1, 1, 3. Okay, so this is 4 volt. This is 4 volts. And here I am getting 2 volts. Here I am getting 2 volts. Okay. Consider if I connected this to ground, the potential here is 0, 0, 0. Here 2 volt. If here 0 and here 4, here 0 and here 4, 1 is dropped, it come to here, 1, 4. Here it is then 3 volt and here 0 volt. 3 volt, 0 volt, 2 volt. So now they ask you relative velocity. So relative voltage. V, Y we are getting 3 volt, Vx we are getting 2 volt. They are asking V x relative to y, so that is we are can write same equation as velocity. This means 2 minus 3, finally you are getting minus 1 velocity voltage. In another manner we can say relative velocity means we have to convert this into 0. Relative to something means relative to 0. We have to convert the relative thing into 0. So for that we have to use negative sign. So if we use the negative 3, then we are getting 0. For the same negative value, we have to use this one. So finally we are getting minus 1 voltage. Okay. So this is how we need to do this kind of questions. This kind of question might come to the exam, and this is 90, 98, 50th question. 50th question. After you finish this one, you can go to the next question. After you finish this one, you can go to the next question. Question number 5. After you finish this one, you can go to the question number 5. After finishing this one, you can go to question number 5. I'm tracing this part. In question number 9, you have to put 9 volt. The battery is 9 volt. Huh? It is 9 volt. Otherwise, you can't do this question. $2,000. Here, it is not an ideal voltmeter. It has a resistance value. So, what is they saying when the remove the from the circuit voltmeter, the ammeter reading changed by 1.5. It will change by 1.5. So That means we can say I. So we are getting total current 1.5 million here. So V equals IR. After remove this, V is 9, I is within that, we will find this is 3000, 1000 plus 2000 is 3000, I we are getting 3 milliamperes. Okay, so change by 1.5 milliamperes. 1.5 milliamperes. Half of the value has changed. Half of the value has changed. Okay. So if we connected this, there are two possible changed. It changed. They didn't say that it is plus change or minus change. They didn't say that. But we have to get an idea about that. So if we have a parallel resistor to this one, the resistance of this is reduced. If resistors are parallel, resistance is reducing. Resistors are parallel, resistance is reduced. Resistance is reduced. So the resistance reduced means current increase. Therefore, it's a plus change. So after you remove this, the resistance increase. After you put this, resistance decrease. So earlier it has to be current 3 plus 1.5, which gives us 4.5 milliamps. Previous it is larger than this value because the resistance is less. Resistance less means current is high. It is 4.5 milliamperes. It is 4.5 milliamperes. Okay. So now we have to find the resistance of that. So we know V equals IR that we have used here. I is 4.5 milliamps, and here what we are getting 2000 into R. So I'll write in this manner. The total resistance we are getting 1000 plus, if this resistance is R, 2000 into R over 2000 plus R, as I mentioned earlier. This is milliamperes, this is 90, you are getting 4.5, and finally this side you are getting 2000. 1000 plus 2000 R, 2000 plus R. So when it goes to this side, you can cancel out 3 zeros. 1 is equal to R over 2000 plus R. So finally R you getting 2000 ohms. This is little simplification. So you are getting 2000. This is the answer, 2000. Answer is 2000, which is fourth answer. Fourth answer. This is the question which has coming from 1998 paper, 55th question. 55th question. Next question, another potentiometer question. Try to do that one. Another potentiometer question. Try to do that one. Try to do that one. I'll give you a time to do that. Okay. Again, I'm telling online classes are not easy. Okay, it's hard to keep concentrate on the screen for a large amount of time, but somehow we have to do. Please put your head or put your mind onto the matters of questions, then it would be easy. Okay, so I'll give you time, 2 minutes, try to do and give me the answer. So potentiometer with the galvanometer, the length they have given as L. In the circuit of the potentiometer resistor. They ask in the internal resistance of the when we connected our resistor, the L is come to L over 2. So we can do this question in this manner. E is equal lambda L. So at the first case, the EMF of the battery is E lambda L. So second case, when we have the battery, it will reduce. So we know that the current is going this circuit. It is not going here. It is always 0. But the current is going to this circuit, which is E gives us V. I'll write in this manner. The EMF is giving us. The EMF is giving us I R plus I R. So IR value is equal half of that. Here what we are getting, E is equal lambda L, and current, here we have this potential, which is half of the L plus IR. Okay, from that we have to get this equation. Here we are getting lambda 2 over L as IR. So the potential has decreased to a half of the previous value. Potential has decreased to half of the value. So if the potential has decreased to R, half of it. Okay, so it says the length change to 1 L over 2. Okay, so L over 2 change is, then the resistance of this circuit, since the current is not flowing through this, the resistance has to be half of the resistance. The V is constant, sorry, I is constant, V has dropped to half of its value, so that means R also has to drop half of its value. So how the half of its values are drop? R can drop. It can drop because if two resistors we can set parallelly, consider this is R and this is R, finally we are getting R over 2. So obviously this has to be R. Option B, that is equal for R. That is correct. It is correct. Okay, one of you has said that the answer, it is correct. Okay, that is R. Again, I'm telling, okay, if you didn't get this one, again, I'm telling. Now, what is happening? First, you have to think what these questions are hard questions. So actually, it is taking for the exam more than 3 minutes. So last in early exam, 50 to 60 questions are very hard questions. Okay, so therefore this will take more than 3 minutes to do this kind of questions. So again, I'm explaining this. In the circuit, the potentiometer resistor R, if a resistor R connected to the length L, it will change to L over 2. What is the internal resistance of the P cell? So if we connected one, what would happen? E potential become E minus IR. Okay, so minus IR becomes half of it. So we are getting here V also half of IR. Then we are getting IR as half of the L lambda previous value. It has become half of the potentiometer value. I is a constant. The reason for that is the R is equal to the value that it connected here. So R plus R over 2, we are getting that. That is the only reason that we can get R over 2. And from that question, we can move to the next part. Next question. Read the question carefully. Read the question carefully. Question number 7. Question number 7. And try to do, I'll give you the time to do that. It is actually it's the 1997 question. 1997, the 28th question is that. 28th question. It is a little bit easy one. It's 28th question. Okay, one of you have finished. B. Yes, your answer is correct. Good. Your answer is correct. Good. Your answer is correct. It's something like this. Five, 6 ohms. EMF of 12 is an ideal ammeter. When the switch is closed, the reading on A. Normally, it's a very easy question. They're asking the reading on A. So this is and this is, we can make 3, 3 and 3, 6. The answer. Okay, so if we consider sigma is equal sigma IR. Okay, this is, there are easy ways also we can do this, but I am doing in this manner. Okay, so it is going here, 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 and here. So this is E means I can use the first closed loop. This is the first closed loop that I am selecting. That is R is 3. This total current is capital I, and here I am getting simple I. So capital I and simple I are the current, and here this side I am going simple I. So sigma is 12 is equal 3 capital I plus 6 simple I, and so I'm getting, this is simple I, and here simple I2, I am getting the same equation. I'm getting 12 is equal 3I plus 6I dash and I dash. So finally I can get this I and I are equal. So therefore I know that the currents are equal. From this I can say I dash and I has to be equal. So this current has to be equal. Again we can say, because this resistance also same, we can say this. Okay, so now I can simplify this circuit into this manner. 3 is here. In these are two parallel circuits, and 6 and 6, just I have to divide that by 3. I am getting 3 ohms. Here we have 3 ohms, and here we have 12. So 12 is equal 3 plus 3I plus 3I. So I am getting 2 amperes. 2 amperes means here it is dividing in, I is 2 amperes. Here it divides in equal 2 parts. So I, simple I dash, both are equal to same, which is 1 amp. 1 amp is going this manner, and the 1 amp is going this manner. So 1 amp is the answer. Answer is B, 1 amp and 1 amp going two sides. Next question, we can move to the next question. We can move to the next question. Okay. Again, I have given you several set of tutorials. I started to give you questions with Microsoft Form questionnaire. Most of you have done that. After that, I have given tutorial. So all the theory parts, including practicals, are in that tutorial. And I have given two question papers, MCQs and structure part, MCQs and structures. Okay, so I have done up to here 7 MCQs. So I'll do another 3 MCQs, and after that I'll move to one structure question. Okay. Next question. The previous question is 1997, 28 question. Go to the question number 8. It is also 1997, 37th question. 37th question. Okay. We have 3 bulbs. If you got the answer, you can send it in here. We have 3 bulbs. We have 3 bulbs. You can see here R. Okay, so finally this is 12 volt. R. The bulbs was labeled as 1.5 volt and 1.5 volt and 0.5 amps. 0.5 amps. Okay, here we are getting 0.5 amps, 0.5 amps, 0.5 amps. So the total current here has to be 1.5 amps. The total current here has to be 1.5 amps. And here it is 12 volt, and the working voltage of this is 1.5. Since it is 1.5, you have 10.5 volts here and 1.5 volts here. 10.5 and 1. So finally you have the voltage V equals IR we can use. V is 10.5 volts, I is 1.5 amps, R is the thing that we have to find. R is equal 10.5 over 1.5, which is giving us 7 ohm. 7 ohms. Okay, 7 ohms. That is 8th question. 9th question. Answer. What is the answer? This good question, and that is not that much hard. Again, it is 1997, the 38th question. 38th question. So the maximum power dissipated is basically happens in the resultant resistance. So resultant resistance of these parts are 2.5 ohms and 5 ohms. The resultant resistance is 2.5 ohms and 5 ohms. The current, do they have given the current? Yes. So they didn't give the current. Each resistor has 20 watt. So 20, 20, 20. So the easiest way that we can do, we can, power is equal I squared R. I squared R. So power is 20. I squared R is 5. So this is 4. I squared. So I we are getting 2. And here what we are getting, we have power 1 and power 2. So power 1 I am getting R I squared R, which is 4 into 5, so 4 into 2.5, which is 10 ohm. P2 I am getting, it is simply circuit, therefore I am getting 20 watt, 20 watt. So the total power PT I am getting P1 plus P2 is 10 watt plus 20 watt. Finally, you are getting 30 watt. It is 30 watt. Then 10th question, it's a little bit hard. 10th question. Try to 10th question. Tenth question. In this below circuit, if the reading of the ammeter converted to 0, the reading of the voltmeter is 2 volt. When the reading of the voltmeter changed to 0, the reading of the ammeter is this one. Okay. Let's check. The final answer. What is the internal resistance of the cell? They ask me what is the internal resistance of the cell. Please. Yes, your answer is correct. Your answer is correct. Good. So okay, so what we can do here, I'll draw the diagram here. Here we have the variable resistor. Ammeter here and voltmeter here. So first one, they are said that first part, voltmeter reading is 2 when the ammeter is converted to 0. Ammeter convert 0 means no current is going. Ammeter convert 0 means no current. That means no current. No current means it only shows the EMF of this battery. EMF is equal to volt. First part that we know from this question. Second part, when the reading of the voltmeter changes to zero, the ammeter is voltmeter zero means when the current is going E minus IR, we discussed that is equal to zero. So current value that they have given, which is 1 amps. 1 amps. So what I can do, subject E, then I'm getting E is equal IR, and E is equal to 2 volts, I is equal to 1, R is the thing that I had to find, R is 2 ohms, which is the answer is fourth one, D. D is the answer. D is the answer. Okay. Okay. Now you have more 40 questions to do. Do all of them. If you have any doubts, you can send me a text if you have any doubt. Okay, so now I'm moving to the next part, structure questions. I'm moving to the structure questions. Structure questions. Take the structure question paper. Take the structure question paper quickly. Take the structure question paper. And read the first question. Read the first question. Read the first question and try to do it. Read the first question and try to do it. I'll give you a time, little time, around 2-3 minutes. Read the whole question first. It is from the Winston Bridge. It is from the Winston Bridge circuit. I'll give you a little time. Try to do it. Finished? Did you read the whole question? The diagram shows the Winston Bridge R1, R2, R3, R4. Write down an observation of the galvanometer when the resistance of the variable resistor is changing from 0 to the large value. 0 to the large value. Okay. First, I'll draw the diagram. Here, I'm getting a Winston Bridge. Something like this. Winston Bridge. And here I have the galvanometer. Okay. That result. A, B, C, D, R1, R2, R3, R4. This is the side. A, B, C, D, R1, R2, R3, R4. This is a variable resistor. Okay. When the resistor is 0, what's happening? When the resistor is 0, so the current is moving from here. Why? Current is going in the minimum resistance side. So part of the current is moving here and part of the current is moving here as well. Therefore, it will get a deflection to this side, or it will show a deflection to this side. What's happening? There is a deflection of the galvanometer reading. If this is 0, it will start to flow from this side. The deflection is decreasing and come to 0 and again go to the other side. So that is the observation that you can get. You have to mention that the deflection of the needle is passing the 0th sign, or needle is changing the polarity, or needle is going to one side into the other side. If you write that for the A part, you will get full marks for that. One of that you need to write. Next one. When the bridge is balanced, or that is in a null point, okay, balance means null point. Balance, current in R2 and R1 and R2 resistors I1 and I2. What are the currents flowing in R3 and R4? Okay, so now we consider when it is balanced. When it's balanced, what would happen? In balance, the current which is going through this one is I1, this one is I2. Since I1 and I2 going here, when it is balanced, means the galvanometer reading is 0. No current is passing through this line. So all the current here comes going here. I1, I1, I1. So R3, the current passing through R3 is I1. Current passing through R4 is I2. Okay, so that is the thing that you need to do. Okay. And the next question that asks, what is the potential difference across BD? It's very easy. So just I told you the potential difference across BD is 0. It is, we can write BD this manner is 0 volt, or you can write it is 0. Just you can write it is 0. It is 0. And next one, when the bridge is balanced condition R1, R2. That was the thing that we wrote. And write the relationship below mentioned potential differences. VAB, VAD, VBC, and VDC. The relations of VAB and AD, VBC and C. So what we can write for them? The relations. Okay. I'll write that in this side. So we are getting the relationship VAB and VAB is equal to VAD. VAD, as I discussed earlier. VAB is equal to VAD. Then VBC is equal to VDC. VPC is equal to VDC. These are the relations that you need to write. These are the relations that you need to write here and here. So if you write both of them, you will get 2 marks. And next one, they're asking us to write the equations with I1, R1. So VAB, we are getting I1, R1. VBC, we are getting I1, R3. VAD, we are getting I2, R2. VDC, we are getting I2, R4. So these are the 4 equations that you need to write. Simply Ohm's law. Simply I wrote the Ohm's law here. Simply I wrote the Ohm's law. Okay. Next question. They said, write an expression. It is an expression for R4. We have write an expression for R4. How we are going to write an expression for R4? So R4. From this one, I can say this set of equation that we wrote earlier, we have to use for this particular manner. So here, this is first one we used. This is the second one we used. This is third, fourth, fifth, and sixth. So you can see AB and AD are same. AB and AD are same. We can write I1, R1 is equal I2, R2. So we can write R1 over R2 is equal I1 over I2. This is first one. So Roman number 1, I'm writing Roman number 1. So second case, I can write I1 R3 is equal I2 R4. So again, I am getting, so this is I2 over R1. Again, I am getting R3 over R4 as I2 over I1. This is my Roman number 2 equation. So you can see the right hand sides of these equations are same. Right hand sides of these equations are same. So I can write R1 over R2 is equal R3 over R4. So this is the relationship, but they asked in the relationship for R4, therefore we have subject R4. When I'm subjecting R4, I'm getting R4 as R3, R2 over R1. This is what I'm getting if I subject R4. This is the answer for the next part. So sixth question, again, it is very easy one. They are asking us to find the R2 value, so R4 value. They have given all the other 3 values. So just you have to substitute values for here. R4 is equal for 50 into 82 over 100. All of them they have given. Okay, finally you are getting answer as 41 ohms. Finally, you are getting the answer as 41 ohms. So now we can move to the C part. I'll give you 2 minutes. Read the C part. Read the C part and try to get the answers. Now they said they are changing these values. Instead of R4, they are using R, simple R. Now finally I'm getting R2, that's R3, R3 over simple R. So available things that we have here, ten ohm, 100 ohm, 1000 ohm resistors, 0 to 100, 0 to 1000 ohm resistance. Ten ohm, 100 ohm, 1000 ohm, 0 to 100 ohm resistance box, and 0 to 1000 ohm resistance box. So they ask you what are the things that we can use. The first thing that you need to know, since R is less than 1, so we cannot select 100 or 1000 for R3. So if we selected that, we become a very large value which cannot compare. So R has to be the smallest value, which is 10 ohm. If we selected this as 100 ohm, 1000 ohms, the resistance value increase, the ratio increase to 10,000 like that. So then we can't do this experiment. It has to be 10. The smallest value, it has to be here, 10. If we consider to select 1000 ohm one, this is 0.1. So then it becomes, the ratio becomes 10,000. So you have to find R1 and R2 in order to give the 10,000. So from these set of resistors, you won't be able to get 10,000 from them. So obviously R3 you have to select as 10 ohm. R3 is 10 ohm. And the next one, R1 and R2. So R1 has to be the maximum value. R1 has to be the maximum value. Maximum value that they are giving is 1000. Since this is 10, it has to be maximum value. Okay. So R2, we know the variable resistor. Therefore, it has to be a resistance box. It has to be a resistance box because it's a variable resistor. So we can't use these three. We can use one of these things. So if you write one of these two things, you get full marks. It doesn't need to necessarily be 0 to 100 or 0 to 1000. Both are correct. You can select both of them. So if you select one of them, these resistance boxes, you would get full mark. R2 is a resistance box. And the last part, they said what would happen if we interchange this and this when it is balanced. nothing will happen. No current is passing through this one. Even though it connected the battery, no current is passing through this one. Even though it connected the battery, no current passing through this one. Therefore, the galvanometer reading is 0. Therefore, galvanometer reading is 0. No current is passing through since this is I is the current is 0. No potential difference suppose this no current. Therefore, galvanometer reading is 0. Answer for the D part, the galvanometer reading is 0. Okay, so we have up to now we have covered 5 hours. So I discussed all the theory parts. I discussed 10 questions. I discussed one structure question. So I also feel it is not enough because the time is not enough, although I did 5 hours. So I'll arrange another session. Most probably it would be maximum 2 hours, 1 hour or 2 hour session to cover this these two tutorials, that means question tutorials. I'll let you know through the WhatsApp group, and I'll do these 2 tutorials in that day. I'll let you know the date. Okay, so I hope you got something from here. If you have any doubt, you can tell me. Go through the all tutorials, go through the all notes, do all the questions. Okay, this lesson is a little bit hard, but I think this seminar might be help you to do questions in the exam as well. Okay, so then thank you for the joining the seminar. Then again, let's meet with another seminar. See you then.